now you can start going. We're on section 3.3, page 74. We're studying aquatic ecosystems. 3.3, page 74. And aquatic means water. So there are a bunch of ecosystems out there containing water. You got your freshwater, you got your saltwater, you got your marsh, which is kind of a mix between the two. We call that scientifically known as an estuary. It has both salt and fresh water.
Brackish.
Brackish is also the word that describes that water. So if we look at the earth, the amount of water on the earth, there's actually very little of it is fresh. Only a small percentage is fresh water, 2.5% of the whole water on the earth. And of that small percentage, 2.5%, most of that is ice. 68.9% is in glaciers, which is ice. And a lot of it is underground, 30%, 31%. So the lakes and rivers and streams that are freshwater are just a tiny, tiny portion. 0.3% of 2.5%. So you're talking about a lot of water on the earth where there aren't living things. But we do have various organisms in the fresh waters, and you see they can form lakes or run down out of the mountains, often from melting snow, and they run down downstream, and as the elevation changes, they slow down, and eventually to what we call a delta and out into the ocean. And you see this is the estuary region. That's where there's fresh water coming in this way, and there's salt water coming in this way, and they kind of mix right there. We happen to be in an estuary region, and that's all our marshes and everything. That's freshwater part of the time and saltwater part of the time. So kind of half and half. As the water runs out of the mountains, it erodes the mountains. It wears them down and eats away at the banks and the rocks and takes all those elements that are in the rocks, like phosphorus. Remember we studied phosphorus was in the rocks? Pulls it down. So in the estuaries, there's a whole lot of nutrients that have been pulled from the rocks up here, and that can be used by living things. So you really get a lot of growth of plants here, and if you got a lot of plants, then you got a lot of animals eating those plants. Estuaries are the major areas of life, and they're the major breeding grounds for fish. I don't know if you know this, but there's only about 10% of the fish in the sea left. 90% of the fish in the sea are gone in the last couple hundred years. Where'd they go? Well, a lot of them disappeared from fishing. A lot of them disappeared from pollution. But you know what the major cause is?
Right.
It's the disappearance of our marshes. People have been filling in the marshes to build houses and stuff. And all you got to do, a marsh has some mud in it. You put more dirt on top of the mud, and then you can build houses and stuff. We've been filling in and losing a lot of our marshes. And marshes, like I said, are the major places that fish lay their eggs. And because when the little baby fish are developing, they have stuff to eat in the marsh, because the marsh has all this plant growth and sunlight and water, and is the basis of the food chain. So there's a lot less fish in the sea than there used to be. Something you should be interested in, especially since we live on the coast here. If you want to take marine biology next year, you can study that kind of stuff in detail. Go on some field trips. We'll check out the marshes. We'll check out the beach plants. It's a lot of fun. Okay, here's a lake. We're going to look at lakes. Now, we don't have any big lakes around here. You all have probably seen the Great Lakes before, and or I don't know if you have or not, but
I have.
They're pretty big.
I've seen one.
Pretty big lakes.
Yeah,
and the lakes actually have what's called stratification. There's different layers where there's different temperatures. In the summer, it can get pretty warm at the top of the lake, because that part is touching the warm air. And then there's a layer a little deeper that's colder, and then the bottom of the lake can get really cold. 5 degrees Celsius is getting close to freezing. You may have noticed this if you've ever swam in a lake. That you go down a certain depth and all of a sudden it gets real cold.
Yeah.
Yes?
Like, in Maine, I used to live in a lake, and like on a really hot summer day, I would go to the bottom of the lake, and it'd be really warm. It'd be really cold.
Really cold.
Yeah. And I wouldn't be. So they left ground.
Thank you.
Now,
Now,
like that explain.
in the fall, you get what's called overturn, and the wind blowing will mix it up, and then it'll all kind of be even all the way through. But in the winter, you can get a situation if it's cold enough where ice forms on the top, and it's actually colder on the top than it is on the bottom. In the winter, the warmest area of the lake would be the bottom, ice on the top, kind of insulating the rest of the lake from freezing. 4 degrees Celsius is not warm by any means, but it's warmer than the ice at the top.
It's 1 degree warmer.
But in Celsius.
Now, the zones of a lake is divided into zones. You have to know these words. New vocabulary for you. The littoral zone is the area of a lake near the edge, where light can penetrate all the way down to the bottom. We call that the littoral zone. And in the littoral zone, you have plant growth, because light penetrates all the way down, plants doing photosynthesis, and then a lot of animals like frogs and insects eating the plants. Well, the frogs eat insects that eat the plants. And so, but you have a lot of life there in the littoral zone. The way I used to remember that, and when I studied it in school, was I remember people litter, right? People litter.
Yeah.
And if they throw their litter in the lake, it's going to be right on the edge of the lake. The littoral zone. You get it? Huh? Good way to remember it? You're welcome. Now, you go further out in the lake, you run into the limnetic zone. The limnetic zone is deep enough, it's shallow enough where light can penetrate, but it doesn't have the plant life because there's no ground for the plants, there's no soil or anything for the plants to grow in. It does have little phytoplankton floating around though. Phytoplankton are small algae that float around in the water and do photosynthesis, and then the fish will eat them. So it does have some life in it, but it's deep enough where there's no solid surface for anything to grow. That's the limnetic zone. And I don't really have a good way to memorize that. Littoral, limnetic, and then down deep you have the profundal zone. Now the profundal zone is so deep that light does not penetrate it. We're talking a lake that's at least 100 or 200 feet deep. We don't really have many of those around here. But some lakes, you go to the Great Lakes, it's hundreds of feet deep, and there will be a depth where light no longer penetrates. And what you have down there is a bunch of filter feeders and crustaceans and mollusks crawling around, and they don't really need eyes for anything.
These zones are only for lakes, right?
These are lake zones.
Okay.
So the lake zones go littoral, limnetic, profundal. And here it shows some of the various organisms. These are the phytoplankton that can do photosynthesis. And these are little tiny creatures called zooplankton or zooplankton that eat the phytoplankton. You remember learning about those?
Yes.
They're both microscopic. And if you take marine biology, we drag little nets out there and we capture these things and we look at them under the microscope. And it's cool stuff.
Do we put them back afterwards?
No, just
not
cool. You ever heard of a bog?
Yeah.
Areas of land such as marshes, swamps, and bogs that are saturated with water and support aquatic plants are called wetlands. We have a lot of wetlands around here. If you ever go to the Okefenokee Swamp, that's considered a wetland. There's pretty much water there all the time. But you can also get plant growth and trees and lots of animals. If there's lots of water around, you're going to have lots of animals because there's plants, got plenty of water to grow, and you have animals eating the plants. So we've got a lot of wetlands around here. Now, this is looking at, we're now on page 78. I'm sorry, 79. this is looking at the different areas of the shoreline in a marine ecosystem. Now, when I say a marine ecosystem, I'm talking about saltwater. Marine means saltwater. Okay? So in a saltwater ecosystem, you have different areas of the shoreline. You have your spray zone, high tide zone, mid tide zone, low tide zone. The low tide zone is always covered with water. So organisms live here that can tolerate salt water 24 hours a day. The mid tide zone is only partially covered. When the tide comes in, it's covered, and when it goes back out, it's uncovered. So the mid tide zone has organisms that are kind of different from these because they have to just tolerate salt water sometimes. For instance, you might see oysters in that zone. Oysters can tolerate salt water for a while, but they can tolerate no salt water for a while. You see the tide go out, and you see the oyster beds, right?
Yeah.
And they can just kind of close up their shells and live in there with water until the next tide comes in. And then they open up and filter feed.
But they can't deal with it forever.
They cannot deal with it constantly. You know why? That's a good question.
Why?
Why can't oysters? Why do you hardly ever find oysters? If you look at oysters on a dock, you know, on a post, you'll see them just in an area. There's none of them real high, and there's none of them real low. Why are there oysters not underwater 24 hours? There's a reason.
Because they need to breathe.
It's because there are little mollusks
They get eaten.
that crawl up and drill holes in oyster shells
They get eaten.
and exist on the side of the oyster shells and
Those
will
little-
eat the oysters.
Those little like bumpy things on the outside of the shell.
I don't know. But anyway, they'll drill holes, but they can't survive when the tide goes out. So you don't get oysters down there. They'll die, they'll be eaten. And too high, they can't eat enough. There's not enough filter feeding going on. So you find them in the mid-tide zone. Now the high-tide zone is only covered with water for small amounts of time, maybe 1 hour a day or 2 hours a day. That's your high-tide zone, so you have to get different creatures there. And then your spray zone just has some splash coming up. It might be covered by water on days when there's storms and things. So just a few times per year. So you have, if you look at it, if you kind of blur your eyes and look at it, it looks like it's stripes. It looks like it's striped. The colors of this, there's different organisms living at different levels, and it kind of makes it striated is the word, the scientific word for
It's
it.
an Oreo on top of it.
It's like an Oreo here?
Yeah.
Yeah.
But like quadrants.
You're not saying that.
The names of the ocean zones. You need to know those too. Right here, Bennett. We have the upper zone.
Dolphins.
It's called the epipelagic. The word pelagic means ocean water.
Yep.
Pelagic means ocean water. So epi means above. So the epipelagic zone is the top ocean water where light can penetrate. There you have lots of plankton floating around doing photosynthesis and animals eating the plankton.
Dolphins.
Then a little bit further down, the mesopelagic zone. Meso means middle, that's here. And light cannot penetrate down there. So that's a couple, 200-300 feet down. And then,
Wait.
oh wait, I'm sorry, light does penetrate there in the mesopelagic zone. It
What
does
about
not
below it?
penetrate in the aphotic zone.
Yeah.
Aphotic means no light.
Photosynthesis.
Bro, wasn't
No
anything,
photosynthesis, no light.
Wasn't
That's the
anything
aphotic.
pointing into like that middle zone?
That's this line is supposed to go there. So epipelagic, mesopelagic, aphotic, and then every once in a while it gets so deep they call it the abyssal zone. This is down about 5 miles deep, and it's not everywhere. There's only a couple places in the ocean where it actually gets that deep. They call them deep ocean trenches. And it can go down 5 or 6 miles deep, and the pressures there are really intense, but there's still things living down there. There are mollusks and squid and
there's
worms
creepy
that can
things
live
like-
down there and
creepy
withstand
things
it.
like
I'm sure you had.
Lanternfish.
Stop writing
Question?
on me.
She stole it.
Oh, you're gonna ask about the lanternfish?
No, it's just I'm trying to talk and you're like doing stuff on my back.
From here and below, listen. From here and below, since there's no light, it's completely dark down there. There's a lot of organisms that create their own light. And so you get your lanternfish, you get phosphobioluminescent is what we call a lot of jellyfish glow. And they use that their light to find one another. Like if you want to mate with someone and it's completely dark, if you're glowing, you may be able to find them.
No, it's really creepy.
We're done.
Now I want to continue showing you my
Oh, your pictures?
pictures from Ecuador.
Thanks, bro.
Do you want to tape this? I would say.
No, you can cut that off. Thank you. It's Willis out. Read 3.3.